Hello students, and welcome to today's chemistry class for S.S.1. In today's class, we are going to take a look at gas laws, but we'll be taking part 3 of the gas laws. Before we proceed, I want us to take a look at our lesson objectives. At the end of this lesson, the learner should be able to state Graham's Law of Gaseous Diffusion, state Avogadros Law, state Gay-Lussac's Law, and carry out simple calculations on the laws above. Let's now take a look at Gay-Lussac's Law of Combining Volumes. Gay-Lussac's Law of Combining Volumes states that when gases react, they do so in volumes which bear a simple ratio to one another and to the volume of the products formed if gaseous, provided that temperature and pressure remain constant. Now, a good example of this, for the reaction nitrogen reacting with hydrogen, that is N2 plus 3H2 to give us 2NH3, that's ammonia. You will see that one volume of nitrogen combines with 3 volumes of hydrogen to give us 2 volumes of ammonia. All this you can see are in simple ratios to one another, agreeing with Gay-Lussac's law. So let's take a look at a second example. Consider the reaction 2H2 plus O2 to give us 2H2O. A. What volume of steam is formed from 20 cm cubed of hydrogen and 20 cm cubed of oxygen if mixed together? B. What gases is or are in excess by the end of the reaction and what amount? So let's take a look at the solution now. The ratio of their volumes is 2 volumes reacting with 1 volume to give us 2 volumes. You can see it from the equation of reaction. 2 volumes from hydrogen reacting with 1 volume of oxygen to give us 2 volumes of water or steam. So 20 volumes will need 10 volumes to give us another 20 volumes of water. Remember, 2 to 1 to 2. So 20 to 10 to 20. That means 20 cm cubed or volumes of hydrogen will combine with 10 cm cubed or volumes of oxygen to form 20 cm cubed or volumes of steam. And the answer to question B is that oxygen is in excess by 10 cm cubed. Why is it so? It is because from the question you were told that 20 cm cubed of oxygen was provided in the reaction, but only 10 cm cubed was used. So you deduct that 10 that was used from the 20, you are going to be left with 20 cm, you are going to be left with 10 cm cubed of oxygen. Let's now look at Avogadros Law. This law states that equal volumes of all gases under the same temperature and pressure contain the same number of molecules. So, for example, in the reaction 2H2 plus O2 to give us 2H2O, you would see that 2 moles of hydrogen is combining with 1 mole of oxygen to give us 2 moles of water. Now, volume of ratio of reactants to products will be 3 to 2. This means if the amount of gas in a container is increased, the volume increases. If the amount of gas in the container is decreased, the volume decreases. That is, volume is directly proportional to amount N. And as before, you can always put a constant and then change the proportionality sign to equality sign. That's what you see on your slide there when we have V is equal to N and that will mean V divided by N is equal to C, the constant, and that also means V1 over N1 should be equals to V2 over N2. Let's now take an example. What volume of oxygen will be required to obtain 100 cm cubed of sulfur 6 oxide from sulfur 4 oxide? Solution: SO2 plus half O2 will give us SO3. That means 1 mole of SO2 will combine with half mole of oxygen to give us 1 mole of sulfur 6 oxide. By Avogadros Law, you will see that 100 cm cubed would need 50 cm cubed, which is like half, to give us 100 cm cubed. The volume of oxygen gas is equal to 50 cm cubed, which is the answer to that question. Let's now take a look at a second example. A balloon with 4.00 grams of helium gas has a volume of 500 dm cubed. When the temperature and pressure remain constant, what will be the new volume of helium in the balloon if another 4.00 grams of helium is added into the balloon? Let's now take a look at the solution to this question. Using Avogadros Law, V1 over N1 is equal to V2 divided by N2. That will mean 500 dm cubed for V1, and V2 is unknown. N1 is 4.00 divided by 4.00 grams per mole. That will give us 1 mole, and N2 will be 8.00 grams. Don't forget, they said another 4.00 grams is added. It will now double, and that will give us 8 divided by 4. That will give us 2 moles. So using that, V1 over N1 equals V2 over N2. We are going to make V2 subject of the formula. When we impute the figures, you will see we are going to have a final answer of 1000 dm cubed as our answer. Let's now move on to Graham's law of diffusion. Graham's law of diffusion states that the rate of diffusion of a gas, R, is inversely proportional to the square root of its density, D. Now, you can see on the slide, rate is inversely proportional to square root of density. Or you can say rate is inversely proportional to square root of molar mass, because density and molar mass have been found to be directly proportional to themselves. They are directly equal to themselves. So if density is increasing, molar mass is increasing. If molar mass is increasing, density is increasing. They are roughly the same thing. Now, let's see how we can compare two gases, where K is the proportionality constant. If we compare two gases A and B with rate of diffusion RA and RB respectively, and then dA and dB for their densities, then we are going to have a formula: RA divided by RB is equal to dB, square root of dB divided by square root of dA. So if we have two gases and we're going to compare them, call one of the gases A, call the other one B, and use this formula. You'll be able to solve problems on Graham's law. Now, let's look at the rate is the reciprocal of time. So we're looking at how Graham's law, the rate of diffusion of a gas compared to time. So the rate is inversely proportional to time. By substituting RA is equal to 1 over TA, and then RB is equal to 1 over TB. So from the equation above that we just finished now, you will see that if we make this substitution, we are going to have RA divided by RB is equal to TB divided by TA, which now is also equal to square root of dB divided by square root of dA. But also remember that vapor density is equal to half of relative molar mass of a particular gas. Generally, Ra divided by Rb is equal to Tb divided by Ta is also equal to square root of dB divided by square root of dA, which is also equal to the square root of Ma divided by square root of Mb. Remember we said molar mass and density are directly proportional to themselves, they are equal to themselves. Let's now take a look at an example. What is the relative rate of diffusion of ammonia NH3 compared to helium? If it takes helium 20 seconds to diffuse, how long will it take ammonia? So let's take a look at the solution. From our equation, Ra divided by Rb equals square root of Mb divided by square root of Ma. We can call ammonia NH3 to be Ra and then helium to be Rb. So this means RNH3 divided by R helium is equal to the mass of helium divided by the mass of ammonia. Now the rate of ammonia is unknown, that's what we're supposed to calculate. Then the rate of helium is 20 seconds, that was given in the question. The mass of helium is 4, and then the mass of ammonia is 17, that is nitrogen is 14 plus hydrogen, which is 1 in 3 places, so that means 17. Now if we impute these figures into our equation, we go ahead and evaluate the right hand side. Then now we multiply, you will see that we are going to end up with the rate of ammonia to be 9.8 seconds. So let's take a look at a second example. 200 cm cubed of hydrogen diffused through a porous pot in 40 seconds. How long will it take 300 cm cubed of chlorine to diffuse through the same pot? Now the solution. 200 cm cubed of hydrogen diffused in 40 seconds. 300 cm cubed of hydrogen will diffuse in 300 times 40 divided by 200, that will be 60 seconds. So using the equation TH2 divided by TCl2 is equal to the mass of hydrogen divided by the mass of chlorine. Now taking out the data, you will see that the time for hydrogen is 60 seconds, which we just finished calculating. Then the mass for hydrogen is 2. Don't forget hydrogen is 1, but it comes in 2 places. So 2 times 1, which is 2. And then the mass of chlorine, Cl2, is 71, which is 35.5 in 2 places. But the time for chlorine is unknown. So we now impute these values into our equation. And on the next line, you see how we evaluated it, and you see 60 times 5.96, that will give us 357.5 seconds. That is the time to take chlorine to diffuse. Now I'll quickly mention here that the unit of a mole is denoted as mole, M-O-L. And then to calculate the amount N, we use the formula mass in grams divided by molar mass of the substance. Now let's consider the mole in terms of mass. The mole is the amount of substance, element or compound, which has a mass equal to its atomic mass. So for example, 1 mole of oxygen atoms is equal to 16 grams. That is the mass for oxygen. 1 mole of oxygen molecule. Don't forget, when 2 atoms come together, they form a molecule. So 1 mole of the molecule will now be 32 grams, meaning 16 in two places. 1 mole of chlorine atoms is 35.5, which is the mass of chlorine, and then 1 molecule of chlorine will be 71, which is 35.5 in two places. We can also take a look at the mole in terms of number. 1 mole of a substance contains the Avogadros number, and that is 6.022 times 10 to the power 23 particles. So 1 mole of any substance will always contain 6.022 times 10 to the power 23 particles. In other words, 1 mole of hydrogen atom will contain 6.022 times 10 to the power 23 hydrogen atoms. Likewise, 1 mole of hydrogen molecule will contain the same 6.022 times 10 to the power 23 hydrogen molecules. 1 mole of oxygen will contain the same number, 6.022 times 10 to the power 23. 1 mole of carbon will contain the same Avogadros number, 6.022 times 10 to the power 23, while 1 mole of water, H2O, will also contain 6.022 times 10 to the power 23. Why you are saying this, in case you happen not to have understood this yet, if I say give me 1 dozen of biros, you will give me 12. If I say give me 1 dozen of eggs, you will give me 12. If I say give me 1 dozen of chairs, you will give me 12. So long as it is dozen, it will be 12. So if it is a mole, it will always be that Avogadros number, 6.022 times 10 to the power 23. For emphasis, let's take some quick examples. How many particles are in 146 grams of HCl? Solution. If 1 mole of HCl will contain 6.022 times 10 to the power 23 particles. But don't forget that 1 mole of HCl has a mass of 1 plus 35.5. Don't forget, 1 is the mass for hydrogen, 35.5 is the mass for chlorine. If you add up the two, it will give us 36.5 grams. That is the mass of HCl. Now, that 36.5 grams has a total of 6.022 times 10 to the power 23 particles. This now means that if we take just 35 grams, that's the number of particles we have, the Avogadros number. Then 146 grams will now contain X, an unknown number. If we now cross multiply and divide, we are going to have 146 times the Avogadros number, now 6.02 times 10 to the power 23, which will now be equal to 36.5 times X, that unknown. X now becomes 146 times 6.022 times 10 to the power 23 divided by 36.5. This will give us a total number of 24.088 times 10 to the power 23 particles. So if 36.5 can have 6.022 times 10 to the power 23, 146 grams will have 24.088 times 10 to the power 23 particles. With this, we have come to the end of this class. Thanks for watching and see you in the next lesson.